In homework 6.3, we're doing a bunch of different things, radical equations and inequalities, and there's some quadratic inequalities on here as well. I'm going to try to do a handful of problems and make sure we know how to do all of them. I'm going to start with number 18. 18 is a square root equation, and to solve a square root equation, you need to start by getting the radical by itself. You're going to need to do these on a separate piece of paper, by the way. There's just not enough room on this paper. So square root of 6x minus 7 equals x plus 2. Once we have the radical by itself, squaring undoes a square root. And we have to square both sides. If we square the right side, we need to square the left side. And the left side is a binomial. When we square a binomial, we need to make sure we're squaring the entire binomial. And we have a shortcut for how to do that. We square the first term. We multiply these two together and double them. 2 times x is 2x, doubled is 4x, and we square the last one. When we square the right side, it cancels out the square root, and we just get 6x minus 7. What we need to do now is we need to, this is a quadratic. We recognize it's a quadratic, and so we make it equal to 0. Subtract 6x, add 7, subtract 6x and add 7, x squared minus 2x plus 11 equals 0. Okay. From here, we could try to either factor or use the quadratic formula. In this case, it can't be factored, so we're going to do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And this is equal to 2 plus or minus the square root of negative 40 over 2. At this point, we can see that these are going to be imaginary solutions. When we're solving square root equations, we're really not concerned with what the imaginary solutions are, just that there aren't real solutions. So we're going to say there are no real solutions here because both of the solutions here, there will be two different imaginary solutions. We're not really interested in what the imaginary solutions are, just that there are no real solutions. Had we come out with real solutions, we would need to check them to see if they worked, because sometimes they don't. So make sure you check your answers if they do work. The next one I'm going to look at is number 20. And number 20 is a little bit different, because in number 20 there is cube roots. And we haven't done a lot with cube roots, but they're pretty easy. Instead of squaring to undo a cube root, you cube both sides to undo a cube root. And in both of these cases, the cube root cancels out with the cubing, and we just get a linear equation, 2x minus 3 equals 2 minus x. In a linear equation, we aren't making it equal to 0. We isolate the x. We get all the x's on one side and all the constants on the other. So I'm going to add x to both sides and get 3x. And then I want to move the constants over to the other side. I'll go ahead and do that at the same time. I'm going to add 3 to move the constants to the right side. To get 3x equals 5, we divide by 3 on both sides. X is 5/3. We do not need to check for extraneous solutions in cube root equations because there aren't ever any extraneous solutions in a cube root equation. That only happens in even roots. So x equals 5/3 is the answer. The next type of problem I want to look at is a quadratic inequality, and I want to do two of them. I want to do 26 and 28. I want to start with 28, and then I'll come back to 26. Square root of 3x plus 4 less than or equal to 2. So we're trying to figure out what values of x will make this square root less than or equal to 2. The first thing we need to do is treat it like it's an equation. 3x plus 4 equals 2. Sorry, square root of 3x plus 4 equals 2. And we're going to square both sides, just like we would if it was an equation. And we get 3x plus 4 equals 4. We solve, we subtract 4, and divide by 3. X equals 0. What this means is that when x equals 0, this square root will equal 2. But we don't want this square root to equal 2, we want it to be less than or equal to 2. So in order for this square root to be less than or equal to 2, we need x to be less than 0. If x is less than 0, then this square root will be less than 2. So the solutions are that x is less than or equal to 0. Now there's something we need to check, which is we need to make sure that the radicand, what's inside the square root, never goes below 0. So we need, it's basically like a domain restriction on it. We're doing 3x plus 4 can never get below 0 because if it does, we'll be doing the square root of a negative, and that would be imaginary. And so it wouldn't be less than 2 anymore, it would be an imaginary number. So we need to say that that 3x plus 4, the thing inside the square root, has to be above or equal to 0, otherwise we'd have imaginary numbers floating around. So 3x has to be greater than or equal to negative 4, so x has to be greater than or equal to negative 4/3. So we have two things here. X has to be less than 0, but x also has to be more than or equal to negative 4/3. In order to make that true, we need a compound inequality. X is above negative 4/3, but below 0. X is all the values between negative 4/3 and 0. It has to be less than or equal to 0 to make this less than 2. It has to be more than negative 4/3 to make 3x plus 4 above 0. And so x has to be in between negative 4/3 and 0. Let's go back to the one right before it. We solve it the exact same way, and we end up getting this time that since it's greater than or equal to 0, when we solve it, when we do the equation, we get x equals 0. But this time, to make this square root above 2, we need x's greater than or equal to 0 to make this square root greater than 2. When we do the radicand domain restriction, we again get x is greater than or equal to negative 4/3. But this time, all the solutions, since they're greater than 0, are going to be above negative 4/3 already. Since they're already all above negative 4/3, we don't need to restrict the domain. All of these values that are above 0 are also above negative 4/3, and so all the values just need to be above 0. When they go in the same direction, you can kind of think of a number line. One thing said that all of them needed to be above 0. The other one said all of them need to be above negative 4/3. And for both of those to be true, well, in order for both of these inequalities to be true, we need to pick the numbers that are greater than 0. That way they fit both inequalities. On this other one, if we drew a number line, one of the inequalities said that x needed to be less than or equal to 0. The other one said that x needed to be greater than or equal to negative 4/3. And so to fit both of those, it has to be all the numbers between 0 and negative 4/3. The last thing we're going to do is we're going to look at a quadratic inequality. And these are solved initially exactly like it was an equation. So I'm going to rewrite this as an equation. So instead of greater than 0, I want to know where it's equal to 0. And I'm going to factor this. This is x plus 7 times x minus 2 equals 0. X is negative 7. X is 2. These are the two values that make this equal to 0. But we're not really interested in where it's equal to 0. We're interested in where it's greater than 0. And when you have a quadratic that's comparing to 0, what we like to do is we like to make a sign chart. We're going to make a sign chart that compares the values of x to the values of x squared plus 5x minus 14. And we don't even really care what the values are. We just care whether they're positive or negative. Because we want to know, is it above 0? Is x squared plus 5x minus 14 above 0 or below 0? Well, what we do is we start by putting in the zeros we found, and we put them in order from smallest to biggest. We leave a space. Then we put in when x is negative 7. We leave a space. We put in when x is 2. Then we leave a space at the end. When x is negative 7, this is equal to 0. That's what the solution means. This is the value that when we plug it in makes this equal to 0. When x is 2, this is equal to 0. What we're going to do now is we're going to find one number in each of these sections and compare it to 0. So any number that I pick that is less than negative 7, I want to know whether this quadratic will be above 0 or below 0. And it's really easy to see in the factored form. If I pick a number less than negative 7, for instance, negative 10 is a number that's less than negative 7, what I'll end up getting is that negative 10 plus 7 is a negative. Negative 10 minus 2 is negative 12, which is a negative. And a negative times a negative will be a positive. I don't even care what the numbers are. I just care what the sign is. This will be true for any number. Like I can think of negative 10, but any number less than negative 7, when you add it to 7, will be a negative. Any number less than negative 7, when you subtract 2, will be a negative. And so you get a negative times a negative is a positive for all numbers less than negative 7. Next we think about any number between negative 7 and 2. So you could think about a specific number, like 0 is between negative 7 and 2. Or you can just think generally. If we do any number between negative 7 and 2, like 0, 0 plus 7 is 7, which is a positive number. 0 minus 2 is a negative number. And a positive times a negative gives you a negative. The last thing is all the numbers greater than 2. If we pick any number greater than 2, for instance, 5, 5 plus 7 is a positive, 5 minus 2 is a positive, and a positive times a positive is a positive. Now, it didn't have to be 5. If you think of any number bigger than 2, any number bigger than 2 plus 7 is positive. Any number bigger than 2 minus 2 is a positive, and a positive times a positive will be a positive. What this tells us is that for all x values less than negative 7, the y value will be positive, or the value of x squared plus 5x minus 14 will be positive. For all values of x greater than 2, the value of x squared plus 5x minus 14 will be positive. And that's what we're looking for. We want to know, when is this value above 0? Well, that happens here and here. So the solutions are that x could be less than negative 7, or x could be greater than 2. If x is less than negative 7 or greater than 2, the value will be positive, which is above 0. Hopefully that helps.